Mapping Association. We welcome you to our first in a series of webinars with GTMA Technical Committee chairs. We are beginning with a very new endeavor for GTMA in the aviation side of transportation. And GTMA's mission is to try to get the most out of transportation data in order to help those agencies that are directly involved in improving planning, improving safety, improving the management of the networks and the system. And we are working very hard to educate policymakers and the public on the importance of data. So whether it's roadway, waterway, airport, rail, transit, we want to make sure that they understand the value of these data sets. With that in mind, we have started a new Aviation Data Technical Committee. And today, we're going to turn some time over to our new committee chair, Grant Bishop. We're very fortunate to have Grant as the committee chair. He is the COO of Stratech Aerospace Incorporated. And we could not have asked for a better person to kind of lead us in this new direction. He has over 30 years of experience in many different leadership endeavors, including combat aviation, international and defense related both companies, technologies, and so what we're going to do now is turn some time over to Grant to talk about what's happening as it relates to data in aviation and about the Aviation Technical Committee. So with that, Grant, turn it over to you.
Well, thank you, Robert. I'm really excited to be part of the GTMA team. This whole endeavor with the new advances we have in collecting data is really important for all the industries that you've got listed: highways, waterways, transit, rail, and of course aviation. And today we'll just spend some time going through where we're at currently on the aviation side, and look forward to meeting the folks on the line today out at the GTMA conference in June. And what we're looking for is coming together and making this a better place with the collection of the data, making sure that we remove those roadblocks that may be out there as far as regulations and things that don't get caught up with the technology that's advancing much quicker. So with that, we've got the slide up here with the GTMA mission. And we can come back to this, but basically the whole focus of today is making sure we support that mission, and we'll talk about how the aviation portion of it will be supporting that. And the what I want to go through initially is where we are at as far as collecting data today. Let's see here. Can you hand me the controls so I can change the slides?
Grant, I believe you I'm
having a little challenge here. There we go. Okay.
Okay, great.
Okay, so the importance of GIS data collection. If many of you are probably very familiar with the aviation industry, but if you're not, I'll just do a review here. There's a saying, safety is always paramount in aviation. And with the collection of data, in the past, if you show up to an airfield, as an example, they will have a airport layout plan, which will have all the various attachments, and there'll be various limitations on where you can build things, the height at which you can build them. the surrounding area of buildings that can be built to make sure that approaches for the aircraft are kept clear. So you have in the past a lot of different agencies coming in and making sure that basically the funnels of airflow into that airfield on takeoffs and landings are clear of obstructions. I mean, it makes complete sense. And the challenge they've had in the past is that to bring all these agencies together to make sure that when somebody constructs an approach with a various antennas or lighting or whatever the case may be, that needs to get onto that airport layout plan. And unfortunately, there have been incidents in the past that resulted in accidents where those connections didn't quite happen correctly. And obviously they get highlighted when there's an accident. You will see that in some cases buildings have gone up around the surrounding airfield that are higher than they're supposed to be, which causes an obstruction to the aircraft. So one of the really important parts of this data collection is suddenly we are going to have a cloud of data that will have every point on that airfield, whether it's attached to the ground, whether it's something that's growing beyond the boundary of the airfield, but all of that can be shaped into a three-dimensional model so that airfields will now be able to say, you know what, we actually have an obstruction out here that we didn't know about, or hey, those trees are going too much. And it's all in the case of safety so that we can make sure that the flying public gets in and out of those airfields safely. And so by having this data, we are able to improve the approaches to airfields. Now, the importance of having those improved approaches not only helps the safety aspect, but it also helps the business aspect of the airfield. There are a number of airfields out there now that, from our previous technology in aviation, an aircraft would have to come straight in and descend at a 3-degree glide path. And let's say in the case of an airfield, there may be a mountain or some terrain feature that blocks that nice 3-degree glide path, and it's 10 miles away from the airfield. Well, that causes a different type of approach to be made, and what it means is that certain aircraft, whether it's based on their internal regulations or their approaches that they're allowed to fly, may or may not be able to service that airfield. And with the advances in GPS in the aircraft, now we can actually make approaches curve and go through and avoid those obstacles. And so, once again, this collection of data and creating a cloud, and as that cloud of information around that airfield is available, can now be fed into the other side of the aviation house, which is designing approaches into various airfields. And now you may find that an airfield that once was not able to be serviced by an airline can now be serviced by that airline because we now have that information that's been missing. And if we'd done it from the previous technologies, it would have taken us forever, and it wouldn't have been reliable. And the other great thing about the data collection is that it's repeatable. You know, you can't, especially with various things that change, whether it's nature or building, you've got to have something repeatable so that you can go in on an annual, quarterly, or whatever the basis needs to be for that particular area and ensure that there is safe approaches for the aircraft. And the only way that you can do that is by the collection of the GIS data. And once again, because that data is going to be collected on the airfield and then beyond, there are some airfields that will need data collected from highways to be shared, as well as some airfields that actually have waterways at the end of their approaches. So that you can see the great thing about bringing all these together into one solitary cloud or a shared cloud will allow that transition for aircraft. That's the very important thing, is that an aircraft at 24,000 feet is not going to run into anything. But once it starts coming down to land or take off, that's when all those data points are important in making sure that the aircraft has a clear path to a safe approach and landing. The other part of that, and why this data collection, these are all knock-on effects. It's almost like a domino, is the improved efficiency. The FAA has gone on a venture, and it's now into it a few years, called Next Generation or Next Gen. And what they're trying to do is make our national transportation system better. There's estimates that there will be 1 billion people traveling in the air by 2020. That's a lot of people. And what it means is that you have to have efficiency, because it's not like we're building airports each and every day. You've got to take what you have and make it more efficient. So they've already started that with these GPS approaches. You'll see that aircraft now are not flying sort of these freeways in the sky that were established by jetways. They're now able to go direct because they have GPS data, which can be adjustable as they share information like weather that's found. They can bend the route to go around the weather without putting too much of a kink in the system, so that aircraft can get from A to B as they've estimated and planned. Because at the end of the day, all those aircraft flying to a certain point have to share that runway. And once again, if we get that data and we can take that cloud of data, and it's got important features like the friction capability of the surface, the points around it. Can we get bigger aircraft in? All those little bits and pieces will add up and help make the system much more efficient. And we can share that data, with everyone. That's the other great thing about it. There's no physical attachment to a piece of paper. It's in the cloud, and we can all access it. The other knock-on effect is the improved infrastructure. As we collect data around an airfield, we will start to notice things that were before relied on by humans doing physical inspections. There are requirements for an airfield to check certain things on a regular basis. Let's say the lights. Have you ever looked at an airfield at night? There's millions of lights out there. And there are requirements that those lights need to not only be on, but positioned properly. Sometimes lights will get knocked over. They will get blown over. Various parts of an airfield can move and change when you have weather conditions come in. Maybe there was a high wind blast. Maybe there were tornadoes in the area. All these things can create change on an airfield. And by having this data in the cloud, we can use it as a baseline for other systems to check and make sure that the airfield is continuously meeting the safety standards that have been set forth by the FAA and others. So in short, what this GIS data collection is going to do is obviously increase safety. And the knock-on effects are going to improve the efficiency of the system and also open it up so that you're going to see more businesses generated that are going to have, once we discover all these things as we collect the data, we'll see that things have perhaps not been maintained the way they should have been. And maybe they need a more rigorous schedule. We may find other things can go longer without maintenance, but it's going to add fidelity to that efficiency and infrastructure of maintaining the airfield. Let's take a look at what the current FAA advisory circular guidance is on collecting this data. You'll find that one of the challenges in airfields and airports is that none of them are the same. There's always a running joke that you've seen one airport and you've seen one airport. So each one has a unique and different circumstance to it. So what the FAA does is instead of coming out and providing very strict, you've got to follow this guidance to the letter exactly every single airport. They provide what's called an advisory circular. Now, there'll be different bits and pieces of it that will apply to the airfield, and in this case, there are 3 advisory circulars currently. There's 1 in draft, so there should be 4 total within the next year that will help in understanding what the requirements are for the collection of data on an airfield, both from people carrying equipment to collect data, vehicles, mobile platforms, and aircraft. And I might mention now that because this collection of data can happen in all sorts of different forms or fashions, and we have all the UAS or unmanned aerial systems out there, we'll also be taking that on as part of the Aviation Technical Committee. So one thing is that if you can bring all your questions as well as any comments you have for making this a better situation, and think about how it will apply not only from the platform you're using, but the platforms out there that are also available, including the unmanned aerial systems. So here is the 3 regulations. The first one is Advisory Circular 150-5300-16. That provides general guidance and specifications for aeronautical surveys, as well as the establishment of the geodetic control and submission to the National Geodetic Survey, for NGS. So in this, there's a lot of discussion about every airport has what's called an airport layout plan, or an ALP, and with the advent of the various technologies, airports are now being guided to create electronic ALP. So you'll see them listed EALP. And I'll have a couple slides later. You'll see the layers that they're putting into these EALPs. And if you go to AC 5300, and I'll take you to the FAA website in just a second here, but you'll see that the guidance here is very detailed, and you should be able to find whatever system that you operate will give you some guidance on how to meet those specifications. So anybody who is doing the survey should be very familiar with these 3 advisory circulars. The second one, 5300-17, deals with the standards of using remote sensing technology in airport surveys. You have to remember, this is a big step for airports. Previously, it would be surveyors going out, covering the airfield, and as you can imagine, the big impact of having people on an airfield is that you can you have to limit your operations, which is a big impact to an airport that's got airlines operating there. So having these remote sensing technologies reduces a lot of the friction that can happen at an airfield. For example, surveys done on an airfield can take up to 3 weeks typically, where you have people working around the clock going out there. They're having to shut down runways. You know, if you're somebody who's booked a flight out of that airport and the runway shut down, you're going to face delays. You may face cancellations. So all of this, these 3 weeks have now had to been plotted well ahead and well in advance. You know, now you're worried about weather, all these kinds of things. And this is one of the big advantages to collecting data with remote sensing technologies. You can now scan an airfield in a fraction of the time, and you can do it at night, which means that the airfield stays open. It means commerce happens. Airlines aren't getting upset, and it's really great. And this AC here provides those standards on the types of remote sensing technologies, so that you can know how whatever your technology is that you're using, how it will be used, if there's any specific requirements, how you integrate that into the system. It's very detailed, and it's a very good product. The next one is 5318, which is the general guidance and specifications for the submission of the aeronautical surveys to NGS and the field data collection and geographic information system standards. So this one is about, I think, 480 pages. Once again, very detailed. And between these three documents, you'll be able to find out how to collect it, what you have to coordinate ahead of time. It even covers airborne collections so that you know who you have to coordinate with within the aviation structure to make sure you have clearance of airspace, what altitudes. It goes into great detail. And the other great thing is if you don't let, once again, the technologies are advancing and maybe somebody comes up with something tomorrow, how does it integrate with this AC? Well, the FAA has a research and development center that goes through, evaluates the various technologies, and will add it to these ACs as they come about. So there is a process so that as new technology comes in, it will be incorporated into these three ACs. The fourth AC that's being written right now is 5300-19, which is really for the small private airfields. In the U.S., we have about 550 commercial airports, and we have many more general aviation and private use airfields. And the standards of using aircraft at a commercial airfield are slightly different from those that are flying perhaps small aircraft that are just doing it through visual purposes. However, because of this national transportation system that we're integrating into, and the fact that we know that aviation is going to continue to grow, and you see small airfields will start to take on more of a role because, once again, the limitation of the runways. You will see airfields out there that may be smaller ones that are going to be used by business jet aircraft or smaller commercial aircraft that before weren't able to be serviced. And so because of that, they want to ensure that the safety standards reach out to those smaller airfields. And that's what's being drafted in 5319 as guidance that may be slightly not different, but will address smaller airfields because they may not have all of the capabilities of the larger airfields. So that has to be addressed so the entire transportation system is safe. Here's that layering that I talked about earlier and how the FAA, this is one of the slides that they present at some of their regional workshops. And if you haven't had a chance to go to one of those are very good. I'll take you to the website here in just a second. But you can see that this is their process. They're putting the layers in just like we have all done out there. But you can see there's a well thought out plan. And here's what the GIS system is at one of the other presentations in our workshop. The big advantage now is that more information from this standpoint is getting to the airfield management, which will make it a safer environment for aircraft to operate in. Now let's just take a quick look at where the FAA has a lot of this information. So this is just taking us to FAA.gov, and I've got the link to this exact page so that you can look at it later and come here directly. But you'll see that the FAA is really embracing the collection of these data clouds, and they have a number of training presentations that you can take online and become more familiar with, whether you're an airport, whether you work at an airport, you're in management, or if you're just a private person, you can attend these workshops. There is a charge for private people, but they're very, very good, and it's a good way to understand how the FAA is approaching everything. You know, they've got, as you can imagine, there's all these different systems, and typically what happens in the aviation industry is whatever the FAA does, the rest of the world starts to follow along. So you will see that many of the standards here will be carried over in some of the international airfields. But once again, you go under airports, and you'll see up here that it's the engineering, design, and construction, and all of these various sessions talk about, like here you've got one on the ACs, and they have excellent detailed descriptions on how they came to the various conclusions that they did. They show you the workflow, and then how you get, once you've collected your data, how you get it into the FA databases. So really good resources on this page. As you can see, when you scroll down here, they even have some great videos. And you've got another link here that takes you into even more of their programs and some of the training courses you can get. But I would highly recommend. You can see these don't take a lot of time, a few minutes, and they give you a really great picture as to what is going on out there in the field. And once again, the real limitation with all this is probably keeping the regulations up to speed with the technology that changes so rapidly out there.
Grant, talk about the technologies. You know, on the roadway side, we certainly know about using friction testing equipment, about the 3D imaging, the mobile LiDAR, and the photogrammetry. What do you see as being the primary technologies that would be utilized for asset and data collection, from debris detection all the way through the system? What would you see as being some key focus areas potentially?
Well, I think the real key to start off with is getting all the airfields, getting their point clouds to have a baseline. Once we have that, and the collection of that comes in multi-tiers. You get there are advantages and disadvantages with every system out there, and it really is a true. It really needs to be truly integrated, where you have, like I talked about earlier, you have the aircraft that are approaching. There are things happening out at 1, 2, 10 miles that need to be seen that are probably best collected by an airborne asset. Then when the aircraft is approaching the airfield, because of the precision that can be done by vehicle-mounted equipment, that is probably the better case to be done there rather than the airborne asset that has some different tolerances. So it comes down to precision and collecting the data that's at the appropriate specification level. One of the things that is a big impact to the airports right now is these larger, they're called sixth generation aircraft. You have like the Airbus A380 and the supersized 747s coming out. Every time an airfield is, you know, it's not like you just fly one of these aircraft in. You have to go and make sure that it has wingtip clearance all the way from touchdown to taxi in. And as we've seen, there's been a couple of incidents at airfields where an A380 has clipped the tail of another aircraft. Once again, if you had cloud data that you could then put into another system that can run and see, hey, does an A380 fit here when these various aircraft, you can run so many of the possibilities. It saves on the way they do it currently, which is they'll send a team out to do a site survey. And you can imagine, and it's usually airline specific. So not only does, you know, you get airline A doing it, then airline B, that not only causes more resources to be used from those airlines, but also for the airport, because they've got to escort all these folks around. Whereas if you run a vehicle around, I'm going to talk about Oakland Airport was done not too long ago, and a 3 to 4 week process was done in a matter of 2 days. And all that data now is available and can be used for all these things. You want to bring an A380 in? Here's the data. Let's take a look. And now you've got that integration of the surface data with building data. You've got that cloud that just makes it so important and so much easier to use. And the other side of that, you're talking about friction. friction has been such a big player in a number of accidents out there. And the challenge is that the friction, at 60 degrees changes when you have other weather and temperature changes. And so if you have those baselines and you can collect that data at those various points, it helps in the fact that currently when a pilot comes in, he lands, and he will tell the tower, hey, they'll say, how was the braking? And he'll say, oh, it's fair or good. That's very subjective. Whereas now, in fact, the FAA is doing a lot of testing on this, is how can we get it down to a number that can be shared with everyone? If you have a runway and it's been poured a number of times because of various changes over the years, the friction is going to be different at different points of the airfield. And so by having that information and being able to feed it into a system that can be fed to the aircraft and ultimately the pilots, it will help them make those smart decisions so we don't have crashes. There's been, like I said, a number of crashes where one person's reported braking, the next person comes in expecting a certain type of braking, and it's changed. And it's once again removing the subjectivity out of the system by these point clouds is going to make the aviation system even more safer.
Maybe that project you referred to, the Oakland airport, maybe that would make for an interesting discussion during the upcoming GTMA, your Aviation Data Technical Committee. I mean, is it possible we could kind of see how that works?
Yeah, I think we can talk to the airport, and as well as the team that did it. There were a number of people involved, and see how the process worked. I think one of the most important things that I heard about it was that not only did they scan the runway surfaces and the taxiway surfaces, but also some of the other areas so that you could see where that integration of how there's pavement changes when it goes into the shoulders of the airfield. You can start to see where the pavement tends to break up sometimes on the outside versus the inside, and all those things help in reducing your cost, because if you can catch a pavement change early, the cost is significantly less to repair it then rather than later.
Well, we talk about just-in-time delivery. I would imagine these technologies could help airports become a little bit clearer into exactly when they need to perform maintenance, when they need to make adjustments, rather than either overperforming or underperforming.
Right. Let me jump to that slide here. It's my next one. I'll tell you what. Let me go into this slide, and then we'll expand a little bit more on Oakland as we get to that slide. So the collection of the data. Another reason this will help is that there's always changes and various projects going on in an airfield, and what typically happens is an airport will make a request for proposal. Then everybody's got to show up, and they drive everyone around to take a look at the site, and then they have additional sites, and you're going through a lot of paper documents. And because of the rules that come with an RFP, you've got to look at the documents that you have, and you only have a certain time limit. Well, what I think that does is it causes a lot of unknowns to occur, because you just can't review everything in that time, and you have to make a lot of educated guesses on these proposals in some cases. So I think once you have cloud data, one of the other things on a future RFP is, it'll be announced, there'll still be an initial meeting, but with that meeting you can put access available for the data cloud, which allows you to go in and take a look before you even get there as to what the challenge is and what you're going to tackle, so that you can make a very educated decision when you're putting these proposals in. And what I find is I think that as see, oh, the risk may not be as high, it will reduce costs for everybody involved. It will make it so that the vendor performing the service understands, oh, you know what, that's not a challenge because we've looked at that. And he doesn't price that into his proposal. So I think all in all, the advantages of that is that you can revisit it. You don't get chopped to a certain time limit when you're doing these things. The other thing the airports will have is a cone of silence, where you're not allowed to have access after that specific time period to make it fair for everyone. With having a point cloud out there, everybody can come look anytime they want for as long as they want. And I think what we'll do is we'll get a better end product for both the airport and the vendors. And it'll also increase competition. You know, you have people that will be able to see things that may not have been able to go there, and maybe you don't necessarily have to go there. You know, if you've got a point cloud, they're so accurate nowadays, and it's only going to get more accurate. So here's, back to Oakland, here's the, I think this is a sort of a watershed moment. With Oakland, their concern is, one of their concerns, I should say, is getting a pavement condition index. And the way that works is airfields are so large that you'll dice and slice it up into different portions, and you'll do a sample of about 5% of that airfield. And what people typically do, and what we've done for a number of years, is people will go out, they'll walk that 5%, making hand notes, taking pictures, making a lot of detail. But that 5% still requires them to shut down parts of the airfield while they do it. And it still takes about 3 weeks to do this whole process. And then what you do with that 5% of data is you put it into a software platform called Micropaver or something similar, and Micropaver will interpolate that other 95% of the airfield to say, oh, well, if this 5% had this much damage, then the other 95% of the airfield should have something similar, or however the algorithm figures it. And it even says in some of the FAA guidance that what happens is the budgeting for the pavement is drawn from this, so that when they say, okay, here's the budget for the airfield, we need X millions of dollars this year to maintain the pavement, it can be up to 30% in error. So the great thing that happened at Oakland is they took a vehicle-based system and drove it around the airfield and essentially collected 95% of that surface versus only 5%. And that 95% of the data can now be put into Micropaver. And so you've taken a lot of the guesswork out of this. And so what should happen is that you have a better reading on every single thing on that pavement, whether it's grooving, friction, whatever the case may be. You'll have derived a more accurate and a more detailed picture of your challenges that you have ahead with the pavement and what you need to manage. And obviously, it all comes down to dollars. You know, you can't repair everything on an airfield. You've got to time it properly based on your budget to make sure that you keep the entire airfield safe and within reasonable limitations. So the result of that scanning that was done, it was done in 2 days, and so it reduced the time. So that makes the airport very happy. That takes out 19 days of having to work with airlines and change schedules and upset passengers, and it's now reduced to 2 days. And it was done at night, which is great, because that's when the airflow reduces. So really, it's a win-win all around, and we get an increased fidelity on the pavement condition. Airfields have to maintain a certain pavement condition to be considered safe. So now we have a more accurate picture, and it makes a more accurate budget for managing those areas that need work. And then the big knock-on effect, the big cost savings for the airport is now you have this data available to you forever. And any other projects that come up, you can see what it was before they started, what it is after. Somebody puts equipment on an airfield, and there's, you can tell, hey, was it placed in the right location? And it just makes it a safer, smarter environment to work in.
Grant, would this help airports who are trying to develop some sort of a where pricing based on the types of, you were talking about some of the larger aviation or airplanes that are flying into certain airports. Would this help them to be able to know what the potential impacts of certain types of aviation on their runways and be able to make some adjustments in that regard?
Yeah, the one thing that is hard to see on an airfield is sometimes you'll get this troughing or grooving, well, not grooving, but you'll get an area where the aircraft have come in and landed over and over again, and if the subsurface wasn't done properly in the pavement, it can start to develop rutting. And so with the systems, and like in particular that were done out at Oakland, they are able to see all of this, and they have a very detailed picture. And what it means is that, you've got these FAA regulations that will tell you what the airfield, the pavement needs to look like. And you have a lot of models that predict when it's going to deteriorate, when you have to repair it. Now you're able to look at it in a very detailed way to see, well, you know what, maybe this surface is lasting longer, or maybe it's not. A lot of the engineering for airfields was designed off the first aircraft wheels, which were on 707s, which were from a long time ago. And now you have all the aircraft that are being built. They have much, they have obviously higher gross weights, and they try to displace them by putting larger numbers of wheels and bogies out there to support all that weight. But of course, instead of one aircraft rolling by, it now, to the concrete, it feels like maybe 7 aircraft rolling by. So those models are being tightened up as we collect more and more of this data, and that's why it's so important, especially, the pavements on highways and things are much more, I think, further along than the aviation community is in collecting the data. And so at the GTMA conference, I mean, that's the whole great thing, is that I think there's going to be a great brain trust of people that will be able to share how they do things and help each one of those industries to make it safer for everyone. There should be a lot of opportunities that come out of this. And could
this even filter down into things like materials testing and et cetera to kind of enforce specifications?
An example of where this data would be very, very important is runways are grooved to help displace the water and help increase the braking capability. One of the things that happens, though, is that that grooving deteriorates as well as fills with rubber. And both of those have major impacts on the capability of the aircraft as it starts to pile on there. I've been on some runways where it looks literally like there is peanut butter spread across the surface because the rubber has not been cleaned off yet. And by having systems collecting this data, especially on a regular basis, you can now make a prediction of when you need to clean that runway. And also you can tell, let's say a runway's been poured and grooved, you can use the systems to determine, has the grooving been done properly. All of these are very small single items, but they have such a big impact when there's an accident. You can go back to the NTSB cases and see where rubber wasn't cleaned, caused an accident. Grooving was incorrect, caused an accident. And now, with these systems, we're able to look into the depths and get that fidelity of that surface, because that's the important part that everybody has to share in this transportation system. The slide I got up now is how can we make this better? Like I talked about just a few seconds ago, is attending the GTMA Datapalooza conference. You're going to meet your counterparts from highways, waterways, transit, rail. We're all going to have our own challenges in those industries, but we probably have a solution that we found in one industry that will help another industry. And at the end of the day, it's all about making it safe. And so I think this is going to be a great opportunity for people to network, share information, learn, and meet future customers and people that will help change regulations that will make it easier for us to get this technology out into the various marketplaces so that we can make it a safer environment. The link I have there is to the FAA website and specifically to that one page that I showed you. From there, you can branch off and find a number of various databases that are on the FAA website, as well as the Department of Transportation, that will all help you with the various aspects of GIS. The other thing too is that I'd ask that send your questions and comments on how to improve the system, what your thoughts are, because we still have enough time that we can do some turning over of stones and finding answers on how things are going in the future, what plans are, and get the right people to the conference that you may want to hear something out of that we didn't think about. I think that just providing us that line of communication will help make GTMA even better each and every year. And then one of the things I would encourage people to do is look at the regulations, especially the FAA and other regulations, and think that there are technologies that none of us have thought about, and they will come along and they will make changes. Make sure that the roadblocks are out of the way on these regulations. The people that are at GTMA at this conference will be the ones that can make those changes. And you know, they're not there to make it harder for us. They're there to help create an environment that we can all be successful in. So, you know, let's put the people together that can make things better for us in collecting the data, sharing the data, making sure that we're all communicating with one another, and if we have things that can help one market, and then let's share it and get it out there. You know, we are the safest transportation country in the world. People look to us, and it's because of things like GTMA that we are making it better and safer, so that others continue to come to the United States and they know, hey, I want to go from A to B, I'm going to get there. I don't even think about it twice. The other thing, too, is training and certifications to ensure standards are maintained. There will be a lot of opportunity out there, and in my vision, the pie is going to continue to grow. The thing that we want to ensure is that people are trained properly and certified to do these operations, because the data is only as good as what we put in. So we want to make sure that the data is correct, collected correctly, and collected in a safe manner. When you run around an airport, especially at night, there's a lot of things that are dangerous. And it's important that people are trained properly. There's a lot of groups out there that provide training, and we want to make sure that we all get that proper training before we go running onto an airfield and cause some problems. So those are things to think about and bring up and make sure that we agree upon on how to make this a better method of collecting the data and getting it out there to all be shared. And with that, that's the end of my talk. I hope it's been informative. Once again, please provide any feedback on things that you want to see. We want to make
Grant,
this
what's the best way for people to get in touch with you?
Well, I'll give you my my email is gcbair, so Golf, Charlie, Bravo, Alpha, India, Romeo @hotmail.com.
Excellent. So if we have any if there are questions, they can send them there. If they have suggestions for the technical committee meetings, they can certainly send that as well. Well, let me just say once again on behalf of GTMA, we're thrilled to have you leading up this effort on behalf of the association and the association's members. And so with that, we look forward to our first technical committee meeting on June 2nd as part of the Transdata Expo and USDOT Datapalooza meetings. As you mentioned earlier, this is going to be a very big opportunity with policymakers throughout the USDOT to begin to lay out some of the issues related to aviation and many other areas as well. So Grant, we thank you for your time this afternoon, and everyone else for their participation. And with that, I think this webinar is now concluded. Thank you.
Thank you, Robert.